Greedy technique. It constructs a solution to an optimization problem piece by piece through a sequence of choices that is feasible, that means satisfying the constraints. Next, locally optimal. With respect to some neighborhood definition, it should be a locally optimal one. Greedy in terms of some measure and irrevocable. The optimization problem is defined by an objective function and set of constraints. We have to satisfy the objective function and the constraints. Applications of greedy strategy. Optimal solution. Change making for normal coin denominations. Minimum spanning tree. Single source shortest path. Simple scheduling problems. Huffman codes. Some other applications are traveling salesman, knapsack problem and combinatorial optimization problems. Next, shortest path, Dijikstra algorithm. It's a single source shortest path problem. Given a weighted connected graph G, find shortest path from source vertex to each other vertices in that graph. The Dijikstra algorithm, similar to Prim's minimum spanning tree algorithm, with a different way of computing numerical labels among vertices not already in the tree. It finds vertex u with smallest sum. The formula used is dv plus w of v comma u. V is the vertex for which the shortest path has been already found. dv is the length of the shortest path from source S to V. W of V comma U is the length of edge from V to U. This is a sample problem for Dijikstra algorithm. The graph given, we are going to start from A. Then remaining vertices are B, C, D, E. For B there is a path from A. So we are giving B of A value, weight from A to B edge is 3. Then A to D there is a path, the value is 7. Here in this minimum is B of A comma 3. So how to shade this edge. Then let the minimum value be A comma 3. From B we have to check. B to C there is a path, value is 4. How to add with this 3. 4, 3 plus 4, 7. Next is there is a path from B to D. So D the value is 2. Already 3. 3 plus 2, 5. E no path. Minimum from this remaining vertices is D. From D we have to check. D to C the value is 5. 5 plus 5, 10. But in the previous step the value is 7. So 7 is minimum. So keep this here. Then for E there is a path, cost is 4. So 5 plus 4 value is changed here. Now the minimum value is 7. Take this. From C there is a path to E. Value is 6. 6 plus 7, 13. This is greater than the previous step value. So keep this value as. Now the minimum is E D comma 9. In each step the selected tree vertex is shaded in this graph. Algorithm for Dijikstra algorithm. Here unweighted table T. The cost table is given as input. Then we are using queue data structure. First we are creating a queue and make the queue as null. First the starting vertex is NQ'd, and while the queue is not empty, we are dequeuing one vertex and we are setting that known as true. For each adjacent to that vertex, that dequeued vertex, we are checking the distance. If the distance is maximum, then the distance we are increasing by 1. We are setting the path as V, then NQ that vertex. Till the queue is empty, we are doing the same process. After that, we are disposing the queue, it is freeing the memory space.